Hello and welcome back to the attic. Today I'm going to be reviewing a small power supply that will be very handy for running instrumentation with PV. It's an isolated supply. It's a little switching power supply that can only supply 300 milliamps at 12 volts. But most of my applications are less than 20 milliamps, and I wanted to see if I could get one that could operate fairly low in voltage or modify it easily. But first, I got a new camera stand. This is a computer 3 monitor stand, and I'm only using a very small part of it, just half of one arm. And connected to that, I have a cell phone cup holder for a car, and I've modified that to fit in this. No expense has been spared. Both of these were free items at garage sales. Don't worry, I'm not going to act or look professional. This is the 6th time I've tried this. Let's hope we can get through it. We have clouds passing overhead, rather big clouds. It's been the rainiest season that we've ever had, that I remember. And as from the previous videos, my inverter drops out, and so then I can't power this power supply. So this is my hot water board. I always plan to use an external supply with this. It's nice because you can handle higher voltages, and also it'll work in a wider range. The actual dropping resistors are ideal. This thing only draws about 12 to 15 milliamps at most when it's operating, and so the resistors don't dissipate that much heat, but they supply a very high immunity to spikes on the line. So I like using them, but you know, you set them up and you're at a fixed voltage, and if you want to change things, you know, add another panel to your array or something like that, you got to do some soldering, and a lot of you are uncomfortable with that. So yeah, this is the option. And like I said, you could just attach wires to these things and screw them right in. And then you can only run one wire over to the positive input, and you're all set. But this is supply, and these are so tiny. I mean, it's amazing. And you know, being that small, clearances aren't very good. So I mean, it doesn't meet UL, but certainly good enough for 200 volts. And there's some odd things about it. See this big capacitor here? This is the 400 volt capacitor. And what's it right next to? The 12 volt output. This is actually the 330 microfarad for the 12 volts. So yeah, there's some place in here and there. There's a full wave bridge rectifier, and they've drilled some little holes to try and get clearance between these two pieces. So yeah, but it's very nicely made, and I'll tell you, this thing is amazing, because most switching supplies will start working 45 to 50 volts. I have a 1 amp 12 volt power supply switcher that I get from China, and you know, it's nice in the case and everything, and most times it will operate around 60 volts. Sometimes you have to go in there. There's a little bump resistor to start it up. They're generally a couple mega ohms just to charge up this capacitor to get the thing to work the first time, and then it self-powers. But this thing starts at just 13 volts. Now I wouldn't run it at that, because obviously the switcher has a FET design for higher voltages and lower currents, but at these low amperages I'm using, it won't matter at all. So I have this thing connected to a power supply right now, and I'm at 10 volts. So we're going to go to 11, 12. So there it is. 13 volts. 13 volts is up to the full supply voltage. I mean, that's absolutely amazing. And so since normally I'd be running at least 30 volts, that's not an issue. Now they come packed like this. I get them 20 at a time. This fits in a nice mailing envelope, and it's a cheap price in shipping. So these end up being about a little less than $1 each, and yeah, 20 is a good number. You're under 20 bucks. Always good to have spares. But these are so useful. So here, I got one here. We'll connect up this one. Let's bring the voltage down. Okay, we're back down to 10 volts. We'll hook this up. So, and they have a nice little LED on the board that'll tell you when the thing is running. Interesting about it is that there's this little cut line here. On the other side actually shows a little scissors, and there's a tiny little hole right there. But you can clip that edge off and you can make the LED not work. I don't know why you'd want to do that, but that's an option. So here I'm at 10 volts, 11 volts, 12 volts, 13 volts, and that's 40 milliamps. It's a 300 ohm resistor. I tell you, it's absolutely amazing. And you know, a supply for $1 shipped, and you know, and that $1 includes the tax. So let's get rid of this. Turn off my power supply. So this is the bare minimum. They come in with a full bridge rectifier. There's nothing to get rid of noise, get rid of spikes, or anything like that. And you go right into a 4.7 400 volt microfarad capacitor. And like I said, this is right next to the 12 volts. Hardly any clearance. Now on the other side you have a, you know, the transformer winding, a diode, a 330 microfarad capacitor, and you have the LED with a 2K resistor in series. You know, it brings down the capacitance. There's two resistors, 19,600 ohms and 3,900 ohms. I haven't really bothered to find out what they're actually for, but I mean, I was thinking I'd have to modify this. Maybe I could make it a lower voltage, or operate. You know, I thought maybe that bumping resistor. Generally, they put like 2 of them in series when they're SMD, and you could like jumper one out to get it to start at a lower voltage. But this thing starts low. You don't have to modify this at all. The legend printed on the thing is 100 to 370 volts DC. There are actually 2 little places that you can go right onto the capacitor if you want, but you might as well just use the diodes. In other supplies, I'll double up the diodes for higher current, or eliminate one of the diodes because you got a diode voltage drop, and so trying to extend the voltage as much as you can as possible. But you know, I would suggest, you know, you put a little MOV across this 100 ohm resistor. That'll give you some spike protection for this. This will also attenuate noise. On the back, I take a little jumper wire, and I go from the minus of the 470 to the minus of this, so that gives me a 3-wire hookup. What's bad about that is that it's fine if you hook it up normally. If you hook it up in reverse, the diode will the bridge rectifier will short out the input, so you don't have reverse voltage protection other than this 100 ohm resistor that would burn up. But you can go right in the full AC side and have total isolation. I'm getting some current monitoring boards, and they're 12 volts, and usually you're always looking for current sensing on the high side, because a lot of times in many devices that you have, the negative is common to the frame of a car or some other vehicle, or you know, you're running a common ground in your system, and it's really hard to isolate the negative lead to a load. But in my case, it's in the high side, and so what I do is I can run one of these power supplies, and I can operate this thing up the board, the current sense board, up at you know, 60 volts or 100 volts without an issue. So like I say, 40 milliamps is more than enough to run most of all these instrument boards that you'd get. So that's it. Less than $1. It works really low at voltage, and it solves a lot of little problems, and it's so small you can bury it anywhere you want. And we got through this without a big cloud coming over. Thanks for watching.